Hello friends, welcome to SSP Math. Today we are going to start particular integral, means how to find particular integral of partial differential equation with constant coefficient. In last video we already seen the complementary function. Now today we will take particular integral and then we can write complete solution of given partial differential equation with constant coefficient is, that is CF plus PI, means complementary function plus particular integral. Now suppose given partial differential equation is phi of d dash into z is equal to f of xy. Then we know that particular integral formula is 1 upon phi of d dash into f of xy. So this is the standard formula how to find PI. जैसे linear differential equation with constant coefficient में हमने लिया था 1 by phi of d into f of x. Same here we have to take 1 upon phi of d dash into f of xy. Okay, so first formula is if. Now how we find particular integral that depends on the function which is given in right hand side of that differential equation. Now suppose if f of xy is equal to x raised to m y raised to m, f of xy equal to x raised to m y raised to m means that is algebraic function in terms of x and y given a. Then how we find particular integral? Then particular integral is equal to 1 upon phi of d into d dash x raised to m into y raised to n. So PI is 1 by phi of d dash x raised to m y raised to m. Now how we find particular integral here? We have to expand this 1 upon phi of d into d dash in ascending powers of d and d dash and operate then x raised to m y raised to n term by term. Same as linear differential equation with constant coefficient में हमने किया था. If f of x is equal to x raised to m, then उस टाइम क्या किया था 1 by phi of d expand किया था up to d raised to m. So same here we have to expand 1 upon phi of d into d dash in ascending powers of d and d dash using standard expansion of 1 upon 1 plus z and 1 upon 1 minus z. Okay, then second formula is suppose given function is exponential function a in terms of ax plus by, means f of xy is equal to e to the power ax plus by. Then how we find particular integral? Particular integral is equal to then 1 upon phi of d into d dash e to the power ax plus by can be written as, जैसे linear differential equation में f of x equal to e raised to x रहा तो हम d replace करते थे a में. Same here put d equal to a and d dash is equal to b, means can be written as 1 upon phi of ab into e to the power ax plus by if phi of ab is not equal to 0. Means if we get suppose here phi of ab equal to 0, then the case fail. And if case fail, then same as linear differential equation, multiply here x, take derivative of phi, that is say phi dash of d dash into e to the power ax plus b, and then put d equal to a, d dash equal to b. When this possible, again if phi dash of ab is not equal to 0 and so on. Okay, then third formula is if f of xy is equal to sine of ax plus b or cos of ax plus b, then PI is 1 upon phi of d square d dash square sine of ax plus b or cos of ax plus b. If sine or cosine is there, then we have to replace d square by minus a square, d dash square by minus b square and d dash by minus ab. Only one sign here, minus ab. इसमें से एक भी नेगेटिव आया तो ये नेगेटिव पॉजिटिव हो जाएगा. Then next formula is if f of xy is equal to e to the power ax plus by into v, where v is any function of x, so v is any function of x, then pi equal to 1 upon phi of d into d dash e to the power ax plus by into v can be written as same as again linear e to the power x plus by take outside and replace d by d plus a, d dash by d dash plus b into v. Yeah, okay, and then proceed, that depends on v. And one formula is general formula, means if these four formulas are not applicable, then try to use this, that is we can write pi is equal to 1 upon d minus lambda into d dash of f of xy is equal to integration of f of x c minus lambda x into dx. And if we take integration of this term, after integration replace c by y plus lambda x, means after integration in final step put the value of c is equal to y plus lambda x, means simply we have to put this c minus lambda x is equal to y. So this is the standard formula. For example, d minus 3d dash a, so put lambda equal to 3 and proceed. Okay, so we will take one problem on this solve. 4 into dabba square z by dabba x square minus 4 into dabba square z by dabba x dabba y plus dabba square z by dabba y square is equal to e to the power x plus 2y. So how we solve this problem here? First we have to use here capital D is equal to dabba z by dabba x and d dash is equal to dabba z by dabba y, and therefore using this, how we write this given differential equation? This becomes 4d square minus 4d d dash plus d dash square into z is equal to e to the power x plus 2y. Okay, so here we have to write auxiliary equation first. You know that complete solution of this partial differential equation is CF plus PI. So first we have to find complementary function and then particular integral. So put here d is equal to m and d dash is equal to 1. Then we can write auxiliary equation is equal to 4m square minus 4m plus 1 equal to 0, because d dash is 1 and d equal to m. So this is quadratic in m. You have to find roots here. So how we find roots? That is equal to m is equal to using minus b plus minus, we can find roots here. So b is minus 4 minus minus plus 4 plus or minus under root of b square, that is 16 minus 4 into 4 4 into 4 into 1 4ac upon twice h 2 into 4. So this 16 minus 16 is 0, that is 4 by 8. 4 by 8 is 1 by 2. So this is repeated roots because b square minus 4ac is 0 and this is quadratic in m, it has 2 roots. So m is equal to 1 by 2 1 by 2. These are the 2 roots here. M equal to 1 by 2 1 by 2. And therefore how we write complementary function here? Complementary function is f1 of x plus 1 by 2 into y and plus x into f2 of plus x into f2 of y plus x by 2. Here y plus mx, so y plus 1 by 2 into x plus x into f2 of y plus 1 by 2 into x. So repeated roots. Okay, then we have to find pi here. For pi we have to use formula. Pi is equal to 1 upon phi of d d dash, that is 4d square minus 4d d dash plus d dash square into f of xy is e to the power x plus 2y. So we have to put here d is equal to a and d dash is equal to b. So e raised to ax plus by, a equal to 1, b equal to 2. So if you put here, then we will get 1 upon 4 into 1 minus 4 into 1 into 2 and plus 2 square is 4. So this 4 plus 4, 8 minus 8 is 0. So we get here phi of ab equal to 0, case fail, and therefore if case fail, then we have to multiply x and take derivative of this. So 1 upon x into derivative of d square is 2d, 2 into 4 is 8d. We have to take derivative with respect to d, not d dash. Okay, so d square का derivative 2d आएगा, 2 into 4 is 8d minus 4d dash and plus derivative of d dash is 0 here because derivative with respect to d dash is constant into e to the power x plus 2y. Here again if you put d equal to a means d equal to 1 and d dash equal to 2, so again 8 minus 8 is 0, case fail. So multiply by x, x into x is x square into 1 upon, take derivative of this term with respect to d, that is 8 d का derivative 1 and minus 4d का derivative 0 आएगा into e to the power x plus 2y. Now yes, this is the pi, that is x square by 8 into e to the power x plus 2y, and therefore final answer is y is equal to cf plus pi is equal to cf is, what is cf? That is f1 of y plus x by 2 plus x into f2 of y plus x by 2 and pi is plus x square by 8 into e to the power x plus 2y. So next problem is solve dabba square z by dabba x square minus dabba square z by dabba x dabba y is equal to sin x into cos 2y. So using capital D is equal to dabba z by dabba x and d dash is equal to dabba z by dabba y, we can write this differential equation d square minus d dash into z is equal to sin x into cos 2y. Okay, so we have to write here auxiliary. First we have to find complementary function, and for that we want auxiliary equation. So put d equal to m and d dash is equal to 1. So using this auxiliary equation is equal to m square minus m, because d dash is 1. And what are the roots of m square minus 1? From this you can take m common, so m into m minus 1 equal to 0 implies m equal to 0, m equal to 1, and therefore complementary function is equal to y1 of, not y1, f1 of y plus m1x, so m1 is 0, and plus f2 of y plus m2x, so this is equal to f1y plus f2 of y plus mx. So this is the complementary function. Now particular integral is equal to 1 upon d square minus d dash into f of xy. F of xy is sin x into cos 2y. So how we find here particular integral? Sin x into cos 2y, and we know formula for sin of ax plus b or only cos of ax plus b. So we have to split this sin x cos 2y using sin a cos b formula. So we know that sin a cos b is 1/2 times sin of a plus b. A is x, b is 2y. So 1/2 times sin of x plus 2y and plus sin of a minus b, that is plus sin of x minus 2y. Okay, now this 1/2 we can take outside into 1 upon d square minus d dash. We split this 1 upon d square minus d dash of sin of x plus 2y plus 1 upon d square minus d dash of sin of x minus 2y. Okay, so this is equal to 1/2 into, if sin of ax plus b is there, then we have to replace d square by minus a square. So what is a? A is 1 here, so minus 1 square means minus 1 square, and a minus ab put karna here, minus d equal to a equal to 1 and b equal to 2. Okay, then into sin of x plus 2y plus 1 upon, here also we have to put d is equal to minus 1 square, so minus 1 square minus a is 1 and b is minus 2 here, into sin of x minus 2y. So we have to replace d dash by minus ab, and if we replace this d dash by minus ab here, then this minus is plus. Same here, if we replace d dash by minus ab, so this minus and this minus is plus here, and again minus, means is equal to 1/2 into, this is 2 minus 1 is 1, sin of x plus 2y, and here this minus 2 minus 1 is minus 3, minus 1/3 into sin of x minus 2y. Okay, so this is the particular integral, and therefore final solution is z is equal to cf plus pi. Okay, so in next video also we will take some problems on this. Thank you.